let's see. Unit 2, Day 2, and this is August 28th. Thank you. Again, put that on there for people watching at home. If they missed a day, they'll know right away if that was the right one. I usually label everything nice and clear, at least that's the intent, so you can find what you need. Quadratic functions and models. You did a lot of stuff with quadratics in Algebra 2, so hopefully a big chunk of this is review, but we'll see. Okay, let n be a non-negative integer, and let all the a sub n's, basically all of the coefficients, be real numbers, where the first one isn't equal to 0. Because if the first one's equal to 0, then it's not really that degree. That's kind of a goofy thing. So that's a weird looking function, a way to write all that out. But all the a's are just coefficients, and those x's are descending by 1. So, maybe it's 7x to the 5th minus 5x to the 4th plus ... 3x squared minus 2x plus 12. Who knows? So don't be intimidated by all the letters there. Learn to read and understand the math terminology. That's a polynomial with degree n, right? The highest power is the degree. Now that's the big picture thing. We're going to be doing that for a couple days. But before we talk about all the polynomials, we kind of want to zoom in and talk about second degree polynomials, which are quadratics. All right, so we're headed toward talking about all of them, but let's talk about a smaller set of them first, because that's the ones that you're probably more familiar with. And we'll get used to those, and then we'll sort of expand our knowledge a little bit tomorrow, the next day. In fact, this whole unit is polynomials, basically. But today we'll zoom in on the second degree polynomials. A quadratic function looks like that. I think you know that, right? That leads to factoring and quadratic formula and complete the square, graphing parabolas, all of those things you spent a lot of time on that last year. So again, hopefully most of this is review. The graph of a quadratic function is a parabola. All parabolas are symmetric with the line that we call the axis of symmetry, or just the axis of the parabola. Remember, that's what throws people off in terms of thank you. That's what throws people off when it comes to even and odd and symmetry and that sort of thing. We think it has even symmetry when it doesn't. Thank you. All the things at once. Now you got 2. Got a spare. Again, I'm kind of cruising through this because I think you know this, but if we hit something that sounds confusing, stop me. The lead coefficient determines whether it opens up or down, right? The A, if it's positive, it opens up. If it's negative, it goes down. The vertex, if we should just label these things. The vertex is that lowest point, or highest point if it's an upside down parabola, right? So the max or the min of the parabola. You can. All right, we're good with lead coefficients, controlling whether it's pointed up or pointed down. To graph a parabola, we like to have the quadratic in standard form. Standard form, excuse me, is where it looks like that. Because that's real. It's really easy to do the transformations. Easy transformations. Right? You go right h and up k, and that would be your vertex. So we really like it when it's in that format, because then it's really easy to graph. number one, sketch the graph of that thing. Well, of course, that thing is not in the format we'd like, so it's hard to know what that looks like. So instead, we're going to force it into standard form. So h of x equals x squared minus 8x. I'm going to leave some space and put a plus 8 out there at the end. Do you know why I'm leaving space there? Complete the square. I want to complete the square because I want it to look like standard form. So I'm glad we did that example earlier. Half it, square it, add it for complete the square. So half of b is negative 4. I square it, I get 16, so I'll add 16. But that's pretty illegal to just add 16 to one side of an equation. That's not right. You can't do that. So what could I do to counter that plus 16? There's sort of two options. One's better in this case, but so I could just add 16 to the other side, but I'd like to keep h of x by itself. So instead I'm just going to subtract 16 over here. Which, I don't know, in some sense seems dumb maybe. Like, why are you going to add 16 and take away 16? That gets you right back to where you started. And you're right, it does. But when we group these terms now, we can factor those, and they'll always factor into a perfect square. And that perfect square will always be b over 2. So x minus 4 squared minus 8. And now it's in standard form. So it's real easy to get the vertex. Be careful. The sign thing is, that x stuff is always backwards, right? So if it's x minus 4, it's right 4. The minus 8 is down 8. So the vertex is at 4, negative 8. And it opens up because a is positive. And there's no multiplier out front, so I don't have to do any like stretching or squishing going on here. So let's go to 4, negative 8. And then we know a parabola does 1, 1, 2, 4, 3, 9, and so on. 4, 16, 5, 25. At some point they're off the graph. And so there's my h of x. I'm labeling it h of x because I'm also going to graph the next one on the same graph. But the key to that whole thing was the complete the square. Because complete the square allows you to force it into standard form, and then it's easy after that. Or at least it should be. So force into standard form with complete the square, or by complete the square. That's sort of the key to the thing. After that, hopefully it's easy for you. Jacob?
With complete the square, how do you like start it? If you have negative 4, which is half of negative 8, how do you do it? Like, how do you exactly start?
You always take half of b.
Okay.
Half of b. That's how you start it. And then square it, and then add it. Obviously there's a lot more going on, but that's sort of the key steps.
So I would square negative 4?
Yes.
Okay.
And we squared negative 4 to get that plus 16.
Oh, okay. And that's it. Okay, I see.
I mean, that's it for this part. Obviously, you can't just go adding 16 without subtracting 16.
Yeah,
It's a good question, but we got most of what we're doing today is maybe not most, but a lot of it is complete the square to force it into standard form. So we're going to get some more practice here. number 2. I don't like doing complete the square with a negative out front, so I can fix that by taking out the negative. X squared plus 10x. And then this minus 16 I moved to the end, and I'm not really worried about it, so I don't have to worry about the negative for that one. So, Jacob, what do I want to take half of? The 10. So that's 5. I square it, I get 25. Now, I need to be super careful here, because what did I just do to the right-hand side of that equation? Yeah, it has to do with that negative. I wrote plus 25, but what I really did was subtracted 25 because of the minus sign out front. So I need to add 25 at the end. So we wrote plus 25 twice, but I did not add 25 twice, right? Because that first one had a negative sign out front. So be super careful with the negatives. And I know it should feel weird to write plus 25 twice. It feels like you just added 50 to that side. But that negative out front is what changed things around. So negative. I factor the inside, but the factor is always b over 2. So you can think about factoring, or you can just write down x plus b over 2. And then negative 16 plus 25 would get me plus 9. So I've got a vertex at negative 5, positive 9. Which way does this one open? Down because of that negative sign. And again, there's no multiplier, so I don't have to worry about squishing or stretching. It's the sort of the regular thing here. So negative 5, 9. And then 1, 1, 2, 4, and so on. How far down do you want your graph to be accurate? Is that the question you're about to ask me?
So for the first one, for each x, it is supposed to be b divided by 2 to find the vertex, but like if you got negative 4, why did you put 4 in the vertex and not make it?
So think about transformation rules. X minus 4 means move it to the right 4. So that's why it's right 4. The X stuff is backwards, the Y stuff is still normal. And so there's my f of x. So I think the key thing on 1 and 2 is that complete the square. I hope the rest of it is pretty familiar stuff. Number 3. And here's 3 more where we'll put them all in the same graph, but it's sort of rigged that they won't overlap at all. So good planning on Miss Murray's part here. Number 3, sketch the graph of that thing. Well, same thing. I don't want to do complete the square with a 2 there, so I'm going to take out the 2. The 7 I'm not worried about because he's just going at the end. So half it, square it, add it. Half of 4 is 2. I square it, I get 4. So plus 4. But again, there's something out front. So I wrote plus 4, but I need to do minus 8 to counteract that. And again, I hope it feels weird to write plus 4 minus 8 and convince yourself that you didn't change the equation when you added 4 and subtracted 8. You didn't really add 4. You wrote plus 4, but you really added 8. So always be careful if there's a number out front. 2 times x plus 2 squared minus 1. So, Mari, what's the vertex for this one?
Oh. 2. Minus 2.
Which one?
Wait.
That x plus 2. What does that do? This is the question you were asking earlier, is why I called on you.
Oh, to the left 2.
To the left 2. Good. So negative 2. And what about the y coordinate? Minus 1. So our vertex is at negative 2, negative 1. Wait. That's right. Oh, the notes I'm looking at are wrong. That's why this looks weird. Negative 2, negative 1. And then, is it opening up or down? Opens up. Okay. What about this 2 out front? What does that do?
You multiply everything by 2.
Multiplies everything by 2. I think I know what you mean. If I think about x's and y's, though, right? Usually it's 1, 1, 2, 4. I don't think you mean multiplies everything by 2.
But you multiply like the y factors.
Good. We multiply the y's by 2, and that will accomplish the vertical stretch. So that 2 is going to multiply the y values by 2. So instead of going 1, 1, we'll go 1, 2 on either side. And instead of going 2, 4, we'll go 2, 8. On either side. And that was g of x. Why don't you try number 4? It's got a negative on there, but it doesn't have any stretching or anything. So you try number 4. So there's the graph of number 4. Pointed down, vertex negative 6, 0. Number 5, I definitely need to take out negative 1/2 to get it off of that x squared. What's the next term going to be, though?
Minus 2.
It's like, definitely negative. 1/2 times what would get me to 4? 8.
What?
Or I could do it this way. 4 divided by 1/2 is 8, but most people aren't thinking in terms of that. You're just trying to think what goes there so that when I multiply by 1/2, I get back to 4. So it's always weird to take out a 1/2, but you have to do it so that you can complete the square, but it just makes the rest of that, or makes finding that middle term kind of tricky. Right. B over 2 is negative 4. We square that, we get 16. But I wrote plus 16, but I really subtracted. What did I really subtract? 8. So how do I wrote plus 16. What do I need to write out here to counter what I just did? Plus 8. Yeah, and that one feels really weird because the numbers are different and the signs are the same, but that negative 1/2 is what's causing that. So negative 1/2. Factor the insides, but I don't really factor it. Or maybe I know how it's going to factor because it's always going to be b over 2. So a vertex of 4, negative 2. It's opening down. And I got this 1/2 thing going on here. So normally it's 1, 1, 2, 4. How do I account for the half? Who gets multiplied by a half? The y coordinates. That will accomplish the squish. So let's see. 4, negative 2. Normally 1, 1, but now 1, 1/2. where you can see it. And normally 2, 4, but now 2, 2. And I guess I could go one more. 3, 9, but now 3, 4.5. 1, 2, 3, 1, 2, 3, 4.5. So I got a skinny one, a normal one, and a squished one. I shouldn't say skinny because it hadn't been squeezed, it's been stretched. So a stretched one, a normal one, and a squished one. Number 6, kind of going backwards. Here's the picture, write the equation. A Jeopardy problem here. So the vertex is at negative 7, 8. So is that x plus 7 or x minus 7? X minus 7. No, x plus 7. Thank you. X plus 7. And how about the 8? Plus 8 or minus 8? Plus 8. And is there anything else I need to do to make that the right equation? I got the vertex. Why negative? Is it going down? And is there any stretching or squishing going on? No. 1, 1, 2, 4, so we're good on that one. Alright, g of x. So vertex at 3, negative 7. So that's x minus 3 and then minus 7. It's positive, so I don't have to worry about that. But it's compressed by a half. If we compress or stretch, they're not going to be, like, they're going to be reasonable stretches or compression. It's not going to be, oh, it's stretched by 3.7. I hope you figured that out. Or it's squished by 1/5. Good luck. No, they're going to be able to figure it out. That one's squished by a half. Probably my favorite mistake on that problem is forgetting to put the square on there. It's like you get the vertex right, you get the half right, and you just forget that it's squared, so make sure you include the square. Number 7, write an equation for f of x, a parabola with vertex 5, 12, that passes through the point 7, 15. Okay. Well, I'm not sure here, but I can definitely get the vertex part, right? X minus 5 squared, and then plus 12. So how do I make it go through 715, assuming it doesn't already? I guess we should check and see. If I plug in 7, I get 2 squared is 4, 4 plus 12 is 16, but not 15. So I can't just be like, oh, let me just stick a minus 1 on the end of that, because that would change the vertex. So how can I change this equation without changing the vertex?
A is 1/3.
I can put an A on there. I can put a stretchy thing on there to make it stretch or compress. So now let's see what happens. So 15 is the y value. 7 minus 5 squared plus 12. So move the 12 over. 7 minus 5 is 2. Squared is 4. So A is 3/4. So 3/4 x minus 5 squared plus 12. Now, I said we would give you nice ones earlier, but I meant if it's graphing, if it's dealing with graphing, you're probably not going to have to mess with 3/4. But this didn't have anything to do with graphing, so that one, not too bad to deal with the 3/4. All right, word problem. Find two positive numbers whose sum is 100 and whose product is a maximum. Two positive numbers. Okay, well, let's just start at the beginning here. Two positive numbers, x and y, whose sum is 100. X plus y equals 100. Whose product is a maximum. So I'm going to say P for product is x times y. But I don't really want to deal with both of those variables in there. So how could I combine, what can I do here? What is y equal to? Like I want to replace that y value with 100 minus x. So P equals x times 100 minus x. Okay, so the the product is, I'm going to rewrite it as negative x squared plus 100x. Okay, so what shape would that make if I graphed it? So that's a downward parabola. Downward parabola. And I'm looking for the maximum. So that'd be right there. Right, to be the top of the parabola. Does that point have any special name? That's the vertex. So, kind of a weird question, but asking us something we know how to do, which is find the vertex. So I'm going to go back to complete the square. Half of b is 50. Square that. Is that 2,500? So this is kind of ugly, but I'm not having to graph it, so I'm not too worried about this. So P is negative x minus 50 squared plus 2,500. And we wanted the vertex. So x is 50. Now we need to be careful here because you could be tempted to say y is 2,500, and that would be the vertex of that parabola, but that's a different y than we're talking about here. P is 2,500. The product is 2,500. The y value is 100 minus x, so that one's also 50. So for two numbers whose sum is 100, whose product is a maximum, both numbers are 50. Justify your answer is showing your work. So I don't need like a paragraph explaining what you did. I just need you to show your work. And I mean, maybe some words to indicate what you're doing. But again, this is not like explain with a short answer. No, just show your work. The profit P in hundreds of dollars that a company makes depends on the amount X in hundreds of dollars. Be careful. So P is profit in hundreds. X is the amount they spend on advertising. What expenditure for advertising will yield a maximum profit? Well, this is really similar to that last problem. Downward parabola. So just find the vertex. It's just a fancy way of asking you to find the vertex. I'm going to rewrite it in the right order. And I got a half to deal with here. So I'm going to factor out the negative 1/2. What's my middle term? So that 1/2 times the middle term gets me to 20. So what needs to go here? Negative 40. And then I can do my half of b is negative 20. I square that, that's 400. So I write plus 400, but I didn't really add 400. Instead, I subtracted 200, so now I need to add 200. So p is negative 1/2 x minus 20 squared plus 430. Okay, now what did it ask me for? What expenditure of advertising? So that's the x value. So x equals 20, but be careful, it's 20 100s or 20 hundreds. So $2,000 on advertising. Okay, so again, make sure you answer the question. If you just put x equals 20, I'm going to give you most of the points, but you're not getting all of the points because you didn't answer the question. Actually, this is not, that's a bad habit to get into, especially for calculus. X is 20. Advertising dollars is 2,000. Right? I don't want to say x is 2,000 because x is 20, but that's not the answer to the question. What is the maximum amount of profit? Okay, well that would be, right, wherever this is, the x value is the advertising, the y value is the profit. So the y coordinate was 430. Now be careful, that's not the profit. Profit is 430 with 2 zeros on it, so $43,000. And the big picture, I think this kind of makes sense. If you spend more on advertising, people will see your stuff and you'll make more profit. But at some point, you spend so much that everyone's already seen it. It's like, probably not getting any more customers on that. You're just, I don't know that it would go down, but I don't know that it would keep going up. Yeah, I guess unless your commercials are really annoying, that people are like, no more, I'm not buying any more of that. Too many commercials. All right, last one. Consider some points of the graph collected in the table below. Wow, this is nice because they give me an equation, they give me a table, they give me the graph. Like, what in the world are they even going to ask for? Because they've given me everything. The x values in the table are equidistant from each other. They differ by 1. Okay, that's a good thing to notice. All right, sometimes they give you tables where it's like random values, and so you got to be careful using those tables. But those consistent differences of 1. Examine the first differences between the y values. So that would be negative 10, and then negative 6, negative 2, and then, we're going up now, 2, 6, 10, 14. Alright, they're not the same. If those first differences are the same, then the function's linear. If they're not the same, and obviously that's not linear. There is some pattern going on here, right?
Yeah.
If the second differences are the same, the function is quadratic. Well, let's see, we're going up by 4, up by 4, up by 4. Let's label those. So that first differences didn't tell us much, not much to conclude, other than it's not a linear thing. But the second difference, we're all the same, that means it's quadratic. Which sort of makes sense, right? Second, quadratic, parabola, x squared. And then we're not going to do examples of the others because it takes forever to write out the table. But if the third differences are the same, it's cubic. If the fourth is the same, it's quartic, ... right? It keeps going that way. Now, if we ask you to figure out which one it is, and you're like at the fifth difference and nothing has happened yet, it probably means you made an algebra or a little mistake somewhere back there. All right, worksheet number next 2, I think.
Yes.